One of the ways you can solve a system of equations is by using matrices and row reduced echelon form, or RREF for short. First thing we need is a system equation. I went with 3 equations and 3 unknowns. First thing I need to do is translate it into a matrix. So what I'm going to do is put the x's in the x column, the y's in the y column, and the z's in the z column. Notice in the first equation there was no y, so I placed a 0 there. So now I need to put it in echelon form. That means the diagonals of 1s going from the top corner to the bottom corner with zeros above and below them. My best chance at a 1 in the first row is if I take the first row and divide it by 3, since all the numbers in the first row easily divide by 3. So one of the 3 row operations I can do is take a row and divide it by a number. So here's row 1 divided by 3, and that will give me my desired result. So first thing I do is I copy the next 2 rows down because they are unaffected by the row operation. And then I take row 1 and divide it by 3. So 3 becomes 1, 0 becomes 0, -9 becomes -3, and 33 becomes 11. And now I'm ready for my next move. I need to make some zeros in column 1. So below that 1, I need to turn the 4 and the 7 into zeros. The easiest way to make zeros is by taking that 1 that we already created and subtracting it from the row below. The row operation we're going to use is by subtracting 2 rows, or in this case, a multiple of those rows. So I'm going to take row 2 and subtract 4 times row 1. But to save space, and since it's really the same move, I'm going to take row 3 and subtract 7 times row 1, so that row 1 gets rid of that 7 in row 3. So for R2 minus R4, I have 4 minus 4 is 0, 6 minus 0 is 6, 5 minus -12, which is positive 17, and -6 minus 44, which is -50. Next, I have row 3 minus 7 times row 1. So I have 7 minus 7, which is 0, -4 minus 0, which is -4, -1 minus -21, which is positive 20, and -15 minus 77, which is -92. The numbers are getting scary, but it'll work. Next, we have to find a new one in column 2, or specifically the position 2, 2. Unfortunately, if we divide the second row by 6, we get ugly fractions. We could try some manipulation using row 3, or we can use the least used of the 3 functions and we can switch rows. Since the bottom row, -420, -92, can easily be divided by 4. There are many ways to signal that you're going to switch rows, but I just like using the 2 arrows showing the swap. As you can see, the swap is pretty easy. I just exchange the numbers from the 2 rows. Now we need to make our new 1 in that position. And we're going to do that by taking row 2 and divide by -4. Notice that even though I swap the rows, row 2 is still the name for the row in the second position. So 0 divided by -4 is 0, -4 divided by -4 is 1, 20 divided by -4 is -5, and 92 divided by -4 is 23. Now we need to make zeros in that column 2 above and below the 1. Now in this one, there's already a 0 in the top row, but we still have the bottom row that we can work with. Again, when we go to our favorite technique for making zeros, we're going to take row 3 and subtract 6 times row 2, where our new 1 appeared. We have 0 minus 0, which is 0, 6 minus 0, which is 0, 17 minus -30, which is positive 47, and we got -50 minus 138, which is -188. Yeah, the numbers are scary again. Now our plan is to make our best 1, and actually it's our only 1. So we need to turn that 47 into a 1. When you get to the last 1, there will be no row switching, there'll be no manipulating of rows. It's either already a 1 or you're going to have to divide by the number that is there. So row 3 divided by 47 is our only option. So 0 divided by 47 is 0, 0 divided by 47 is 0, 47 divided by 47 is 1, and -188 divided by 47 is -4. Now we're in the home stretch. We need to make zeros in column 3, which are all above the 1. Now, Because we've done all the work ahead of time, we're now down to we only have to work with 2 rows, the 3rd row and the 4th row. And so actually the math becomes a lot easier. To get rid of the first row's 0, we're going to take row 1 and add 3 times row 3, because there's a -3 there. We're going to add 3 instead of subtract. For the 2nd row, we're going to take row 2 and add 5 times row 3. And the reason we're adding is because -5 is, well, negative. After doing all that math, we wind up with this matrix here. Notice the diagonal 1s with 0s above and below, and the last column for our answer. Now we need to bring back the variables. The first row is where our x answer appears, the second column is where our y answer appears, and our third column is where our z answer appears. There will be some variance, but we'll discuss that later. So x equals -1, y equals 3, and z equals -4, and that's the answer for the system of equations listed at the top.